word helps you understand the rest of it, is habitat diversity. A real river has slow parts, fast parts, and Abrumit's using her cell phone again. Oh, boy.
Hey, right.
Oh, I'm sorry, tapping on herself. Not using it. And I hate to become such a, what do you call it? A beezy about this. As a victim of fascism, I frankly resent the terminology, but anyway, saying that to an Argentinian is sort of like calling a Jew a Nazi. But anyway, I'm sorry to make a big hassle out of this, but I'm trying to remind myself also, because it is something that I feel needs to change about our culture in general. I'm trying hard at it. Where was that? Habitat diversity, thank you. Real rivers have a diversity of habitats. They have fast parts, slow parts, deep parts, shallow parts, shady, sunny. Think about the bottom of a real river. There's boulders, there's sand, there's gravel, there's rocks, there's leaf litter, there's logs. There's all sorts of different stuff happening. It's a dynamic and varied system. But a canal, the whole point is simplify, get the water out of here. A canal is the exact opposite of a river by design. That's the whole point. And so, in a real river, you get the following. From that diversity of habitats, the rest of this all makes sense. For one thing, you get a stable water temperature because there's deep water that stores temperature, and there's shading and insulation. So real rivers have, first of all, a stable water temperature. That's a very big deal. Second, real rivers have shade. And shade, it turns out, is critically important for water because it gives protection to aquatic life and it keeps the water cold. And cold maintains high dissolved oxygen. Cold is proportional to dissolved oxygen. Third, with the shading, with the deep spots, you get minimal variation in temperature. And with all that diversity of habitats, you get an abundant supply of organic material, like leaves and bird droppings and miscellaneous rotting vegetation and pieces of bark and who knows what. So think about that combination. High dissolved oxygen, shade, diversity of habitats, lots of organic material. That sounds to me like a heck of a food web. You've got decomposers, you've got the bugs that eat them, you've got the amphibians and the fish that eat the bugs, and then you've got all the other stuff that comes to the water to eat the amphibians and the fish and the bugs. With all that vegetation, you've got what we call riparian habitat, which is critical to birds. This is a good combo. That's a whole ecosystem in that river.
No, we're done with it.
One last thing. That's also beneficial to humans because biological activity bioremediates pollution. All those plants will catch the garbage. All the bacterial activity will break down waste. So real rivers bioremedy pollution and recharge groundwater with clean water. That's great. That's good for humans. Let's compare that to a canal. The canal will be literally the exact opposite of everything I just said. So canals don't do a single one of those things. Unlike a river, canals have dramatic temperature spikes. You get daytime heat, nighttime crash. Daytime heat, nighttime crash. Without any consistency to that temperature. Alice is with a cell phone. I know, I am on the crackdown. I'm looking for a law enforcement job, actually. I love enforcing law. I believe in right and wrong, and cell phones are wrong. Did I tell you my park ranger story? Oh, one of my best friends is becoming a park ranger, and he's having this, emotional quagmire, because all of his law enforcement ranger friends tell him not to report his history of drug use, and he's worried that they're all telling him to lie about it, but they spend like thousands of dollars doing background checks on law enforcement people, and if he lies, it's like a federal crime, he goes to jail for 5 years. And nowadays, he's one of the most square people I know. Like, he's got nothing to apologize for. He'd make the best law enforcement person I've ever met. He's like a righteous, good person who's just righteous, super nice guy. But he's got this thing that's like killing him. He won't return phone calls, he's all depressed, he's gaining weight. Like, his girlfriend moved out of the house because he can't deal with his stress. I think that's what I told him. But I guess, whatever. They don't like that. Like if you're working a lot, if you're LEO, like. Okay, here we go. Remember that a canal will do the opposite of all those things. So temperature spikes, no shading, so you've got no cover for fish. You've got no organic materials, so there's no food web. And you've got no deep spots and shallow spots, so there's no diversity of habitat, there's no place for a fish to rest. There's nothing to break the surface of the water. Look at this. See how the top of the water is perfectly flat? So it's got very little stirring, and so with less stirring, you get less oxygen, plus the heat spike dries out the oxygen. So all these do is they just convey pollution to whoever's at the end. And at that side, they deliver unfiltered flooding with pollution.
Nice.
Which is horrible for ocean water quality and for wetlands. Like so many other things in this class, this is a perfect example of us figuring out the best way to do things after we've all done it the wrong way. The funny thing is, if you just maintain riparian habitat, like if you just don't live right on the bank of the river, like you just move back a block or something and keep a little park in front of the creek, you would have no need for flood control. You'd have cleaner surface water, more fishing, more robust ecosystems, better water quality in the ocean. Like, if only we had known earlier to keep the city back from the river a little bit and let the river do its thing. We can debate the feasibility of hindsight. Sure. But for now, I think we should move on to number 26 because I made this beautiful drawing, so I'd like to talk about it. If you don't have the drawing, I'm going to try to fill in all the words for you. Here goes. Water's moving, please look up that way. You can see the river flow that way. The water flows that way. We're starting over here, please look up, with a clean zone in the river. Then we're going to decompose some garbage in it, which will cause a septic, also known as dead zone. And eventually, we'll reach an area where water quality recovers and becomes clean again because water's moving this way past the infusion of pollution here. Question so far. When we speak of biodegradable waste, our big examples in modern society, you should know them, are sewage fertilizer, runoff from cities or farms, and solid waste from farms, slaughterhouses, or the timber industry. Those are solid wastes. I don't know about you, but I throw my apple cores in the bushes and my banana out the window when I'm driving. Banana peels. The reason for this is because they're biodegradable. As far as I'm concerned, it's not plastic, it's not pollution. If somebody minds seeing it, they can look away. I mind seeing asphalt. The funny thing is, if you add a lot of biodegradable stuff to water, you can cause problems. Before I explain all of these variables, there's one principle I need everyone to see. Please look up. Where water and air rub past each other, you get what's called gas exchange. CO2 is usually leaving water and oxygen is usually added to water. Anytime that water and air rub against each other, so if it's windy, if the water's moving quickly, if the water's moving quickly and it's windy, you get even more gas exchange. Everybody got that? So look, ignore everything underwater for a minute and just watch the surface. As water moves past air, you always exchange gases. Always. If it moves faster, you exchange more gases. CO2 out, oxygen in. Everybody see those? Next. Our variables are dissolved oxygen. That's how much oxygen is dissolved into the water. You might remember in your thing on Friday, I'm sorry that your results were bad in this period. Did anybody get a white test tube last Friday? Yeah, who has a white at the bottom? Okay, so from that, I remember we talked about it. You may at least remember the yeast was eating the milk, and in doing so, used up all the dissolved oxygen, and that's what made it white. We call that biochemical oxygen demand, or BOD. And remember, that's microbial. In other words, that's small stuff doing biodegradation, the biodegradable thing. In the process of biodegradation, microbes use a lot of oxygen. So here we go. Watch me. Starting over here, you have a clean zone. In a clean river, fish are happy because there's a lot of oxygen. There's a lot of oxygen because the bacteria don't have much to eat. If you think about it, fish are big, their poo is little, the bacteria that eats their poo doesn't have a lot of food, so the bacteria aren't using up too much oxygen. When the only bacteria food is just fish food. Is that clear to everyone?
For sure.
So remember, in the absence of organic material, of large volumes of organic material, the bacteria have very little to do, which leaves a lot of oxygen that makes the fish happy. Do you guys know that fish breathe oxygen underwater?
That's
Cool. Fish.
It's like water.
Do you guys know that for a period of your development, all of you had gills in the embryo?
Yeah.
Not really.
Why does that move?
I know.
Okay.
Okay. Back to me. You also had a tail, but I'm sure you already knew that one. Okay. Now, when you add biodegradable material, here's a key detail in the story. Bacteria reproduce